Here are your objectives for 1.2. Solve linear equations in one variable. Solve linear equations containing fractions. Ooh. Solve rational equations with variables in the denominator. Recognize identities, conditional equations, and inconsistent equations. And solve applied problems using mathematical tools. Okay? So let's talk real quick about solving linear equations in one variable. Again, I'm not going to do a lot of these because you don't need me to. 2x plus 5 equals 9. Do you know how to solve that equation? What could I do first? Subtract 5. That's what we most commonly do first, right? Is that the only thing I could have done first? No, I could have done a whole bunch of things first, or at least 2 other things first, but we're going to go with that. Okay? What's left is 2x equals 4. To solve for x, I divide both sides by 2, so x equals 2. Is that the correct answer? And you know that because you could check it, right? 2 times 2 is 4, 4 plus 5 is 9, 9 equals 9. That is the correct answer. Okay? Any more questions about linear equations in one variable? Okay? Let's do one like this with fractions, linear equations containing fractions. 2x plus 5 over 3 equals 9 over 6. Well, if we want to get rid of the denominators, which is what I'd like to do, because then we don't have to deal with them at all, I would think about what would be the common denominator between 6 and 3. And you guys know what would be 6? 6, right? And I would multiply both sides by 6, okay? As long as I do it to both sides, it's fine, right? When I simplify this, that's just 1, right? 6 over 6 simplifies to 1. What happens over here? 2. So everything on the left-hand side, I need to multiply by 2. So I would get 4x plus 10 equals 9. Well, now that's just exactly like the problem we did up here, just solving one variable equations, subtracting 10 from both sides. 4x equals negative 1, so dividing both sides by 4 gives me an answer of x equals negative 1/4. And again, we can plug that in. It's quote-unquote a little bit more difficult here because of the fractions involved, but it's not that difficult, right? 2 times negative 1/2 is, 2 times negative 1/4, sorry, I was saying the answer out loud. Negative 1/2 minus 5, plus 5, so it would be 4.5. 4.5 over 3 equals 9 over 6. It's equal, right? Because if I multiplied both numerator and denominator over here by 2, I would get 9 over 6. And 9 over 6 does equal 9 over 6. Okay? Any questions about solving questions with fractions? Okay? Let's do an example of solving rational equations. What is a rational equation? What's a ratio? A fraction, right? So we're solving, again, fractional equations, except this time the variables are in the denominator. Okay? So if I have 4 over x equals 5 over 2x plus 3, we need to make sure we understand how to do this question. Again, if we can get rid of the denominators, that would be ideal. To get rid of the denominators, I figure out what would be the common denominator, and in this case it would be 2x, right? And I multiply each term by 2x. Okay? When I multiply each term by 2x, what happens on this first term is the x's simplify, and I just end up with 8. What happens here is that the 2 simplifies with the 2 and the x simplifies with the x, and I just end up with 5. And what happens here is that nothing simplifies because there was no fraction to begin with, so I just get 6x. And once again, it's just like the problems that we've done before. So I get 3 equals 6x, and dividing both sides by 6 gives me x equals 1/2. Again, I could plug that in. Okay? So if it gives you a problem like this and says, what's the answer set? Sometimes it doesn't just want 1/2 as the answer. If it wants the set of numbers that's true, It wants it in set notation, which means you have to use the pretty braces when you put it in for the answer. Okay? Now, of course, we want to check this. 4 over 1/2 equals 5 over 1/2 times 2 plus 3. Well, 1/2 times 2 is just 1. So 4 divided by 1/2 is 8, right? Because it's like multiplying numerator and denominator by 2 to get rid of it. This is 5. This is 3. Is 8 equal 5 plus 3? Yes, so I know that my answer set is correct. Okay. Another rational function problem that you might see would look something like this. 4 over x plus 5 plus 2 over x minus 5 equals 32. Okay, this one's a little bit more messy, only because when I find the common denominator, when I don't have common terms like I did right up here, they both had an x, right? But those are factors because everything's being multiplied. This is one term and this is one term, and if they're not the same, I need to multiply them together to get the common factor. Okay, so what I'm going to multiply each term by here is x plus 5 times x minus 5. Okay, x plus 5, x minus 5. And if you remember in my class, x plus 5, x minus 5 is actually x squared plus 25. Because I do distribute, and I get minus 5x and plus 5x, and that's a 0, right? So I can go ahead and multiply this last term by x squared minus 25 just to make things a little bit easier. Okay. Can I fix something really quick before we go on? I just forgot to write down the denominator of this part. Apologize for that. So now when I go to simplify to be able to solve this equation, I notice that x plus 5 and x plus 5 simplifies. I notice that x minus 5 and x minus 5 simplifies. And I notice that x squared minus 25 and x squared minus 25 simplifies. So what I end up with is the first term is 4 times x minus 5. And you don't have to write down this step, but I'm going to go ahead and write down this step so we don't lose anything. So I don't lose anybody. And then I have 2 times x plus 5. And then I just have 32 for this term. Now from here I distribute. And I get 4x minus 20. And 2x plus 10 equals 32. Now all that's left is to combine like terms. Gather all the like terms together. And simplify. Okay, so I have 4x and 2x, which gives me 6x. I have negative 20 and positive 10, which is negative 10, equals 32. Once I add 10 to both sides, I have 6x equals 42, and then I divide both sides by 6 to solve for x. X equals 7. Now the thing you have to be careful of when you're doing rational function problems where the variable is in the denominator, is you really have to check. Because what if I did all this work and I got my answer of 5? Well, what happens when I plug 5 in right here? It's 0. Are we allowed to have 0 in the denominator? No. So if that happened, if really I did all my right work and I got x equal 5, that's not a viable answer because that gives me something that can't happen. Okay, so we really do need to check. 4 over 12 plus 2 over 2, which is 1, right, equals 32 over 49 minus 25, so 24. So 4 over 12 plus 1, well, that's 1/3, isn't it? 4 over 12 is 1/3, so 1 1/3 equals 24 over 32, 1 1/3. So I know that this is the right answer. Okay, so because not only does it fit, it makes the equation work, it also doesn't make any of the denominators equal to 0. Okay, feeling okay with rational functions? Okay, so that takes care of our first 3 objectives for the day. Let's talk about identities, conditional equations, and inconsistent equations. Okay. So identity. An identity looks something like this. God bless you. God bless you. X plus 3 equals X plus 2 plus 1. It does. X plus 3 equals X plus 3. What can I put in for X that would make this statement true? Literally anything, right? I could put in a 1, that's true, but literally any number that I put in would make this statement true. So it is an identity. Okay? It's not really something that you understand. It's like a definition. Does that make sense? Okay. Conditional. Conditional would be something like this. 2x plus 3 equals 17. Well, I need to subtract 3 from both sides. 2x equals 14. X equals 7. What value could I put in here to make this a true statement? Only 7, right? I can only put 7 in here to make this a true statement. Any other value I put in there, it's not true, is it? So it's conditional on putting in the right x equals. Okay? Inconsistent. X equals X plus 7. Well, if I'm combining like terms, I get 0 equals 7. Does 0 equal 7? Will 0 ever equal 7? So what value can I put in here for X that would make this statement true? None. There's no value that I could use to make that statement true. Okay? Our last objective says solve applied problems using mathematical models. There's going to be several of these that show up as our last objective. Pretty much, you know what they mean? Word problems. Here's a graph. Can you read the graph? Here's a table. Can you read the table? Here's another graph. Can you know what I'm saying? Okay. Mathematical models, graphs, equations, tables, things like that. Can you do something with them? Can you read them? There's not a whole lot of examples that I can give you unless I just show you a graph and ask you something about the graph. You see what I'm saying? That's what those are going to mean when we get there. Okay? Do you have any questions on these objectives that we've gone over today?